In this video, we will study about surface tension and most importantly, basically, we will discuss about the units, factor affecting the surface tension, Micelles formation and the action of detergents or soaps basically. Surface tension. We will define surface tension as the inward force acting on the upper surface of a liquid or the force in Newton acting on unit length of the surface of a liquid. Basically, surface tension is the force that is acting on the upper surface of a liquid that is responsible for shape formation of rain droplets. And when a force acts from the inside of the liquid on the upper surface of a liquid, the upper surface is stretched and is pushed inward, and that is referred to as surface tension. Surface tension is denoted by gamma. So here are its formulas and units. The formula of surface tension as represented by the definition is force per unit length. Gamma represents surface tension. Your formula is given as gamma is equal to F over L, where F is representing force and L is representing unit length. Following this formula, we have found the units of surface tension as joule per meter square. And joule is equal to Newton per meter. That's why we found another unit, that is Newton per meter. Because Newton per meter multiplied by meter square gives us Newton per meter. Another unit that defines surface tension is dynes per centimeter or dynes meter. Explanation. Look at the picture, the diagram showing two molecules A and B. In order to understand this phenomena, let us consider two molecule A that is present in bulk and B on the surface of a liquid. Molecule A is completely surrounded by molecule equally attracted in all direction, and so force on right side is cancelled by the force on left side, and the force acting upward is cancelled by the force acting downward. So resultantly, molecule A feels no force and the resultant force is 0. When we consider the molecule B, that is not surrounded equally. It is surrounded by a number of molecules downward, but there is no molecule present upward. So there is no force of attraction attracting molecule upward. When this results, the molecule B feels an attraction force downward by the molecules present internally, but there is no force acting upwards, so they feel a stretch. Molecules are attracted downward, they move down, and due to the inward attraction, surface molecule experiences an tension that is called surface tension. Liquid surface behaved like a stretched sheet due to these force of attraction acting, and this is known as the surface tension. This surface tension caused the liquid surface to contract. That is why rain droplets are circular in shape. Proceeding to next slide, that is factor affecting. Now consider surface tension. Surface tension is basically because of the attraction between molecules. When there is a greater attraction, when there is greater intermolecular forces, that intermolecular forces are the forces between two molecules, two atoms. So when there are greater intermolecular forces between two molecules in a liquid, due to these greater intermolecular forces, they are stretched more, they are more strongly bounded, they are more linked to the surface, therefore there results in an increase in surface tension. So surface tension is directly proportional to the intermolecular forces. With the increase in surface tension, with the increase in intermolecular forces, surface tension actually increases. So they have a direct relationship. Surface tension is indirectly proportional to temperature, because when temperature increases, the attraction between molecules decreases, because with the increase in temperature, the kinetic energy of atoms increases and they start moving with a greater velocity, and due to the increase in velocity, due to their haphazard movement, they start moving randomly and their attraction between them decreases. So due to the increase in temperature, the surface tension decreases, because actually surface tension is the reaction force acting between the molecule, and when the attraction between molecule decreases, the surface tension decreases. So with the increase in temperature, surface tension decreases. From this slide, we have studied that surface tension is directly proportional to intermolecular forces, and it is indirectly proportional to the temperature. Critical temperature. Critical temperature is basically the temperature when tension becomes zero. When the surface tension becomes zero, and that is called the critical temperature. Water has a surface tension value of 72.8 into 10 raised to power minus 23 at 20 degrees Celsius. That represent this temperature, that represent the surface tension of water at 20 degrees Celsius. So when we go on increasing the temperature, a point reaches at which the molecules move randomly fastly in a way that the attraction between them decreases to zero, and when at that time when attraction between the molecule becomes zero, the surface tension becomes zero, and that is the critical temperature. That is the temperature at which surface tension becomes zero. Because of the movement of molecules, their attraction decreases. This is the equation showing relationship between surface tension and critical temperature. When we get critical temperature is equal to T, a particular temperature at which surface tension becomes zero, then Tc is equal to T. Then placing the value of Tc as T, we will get T minus T is equal to 0, and 0 multiplied by K is equal to 0, and surface tension is equal to 0 when at a particular temperature Tc is equal to 0. Micelles action of detergents. Consider the detergent part like it is in an amphiphilic substance. Detergents are the amphiphilic structure. They have two parts. Amphiphilic structures are the structures that have both hydrophobic and a hydrophilic part. Hydrophobic part, that is a long hydrocarbon chain, that is represented in the diagram like the head is a hydrophilic part, that is water loving, whereas the tail is a hydrocarbon chain, is a long hydrocarbon chain, that is a hydrophobic part, that is water hating part. So detergents have both hydrophilic and hydrophobic parts. They have both polar and non-polar ends, and so they are amphiphilic in nature. Micelles, as it is represented in the diagram, micelles. Micelles are liquids or molecules that arrange themselves in a spherical form in aqueous solution. When detergents are added to water, and when they come in contact with any stain, any oil, greasy substance, they surround themselves, they aggregate themselves around the structure, like that is in circle. ST represents stain, and when detergents are added to water and they come in contact with stain, they arrange themselves around the stain. As stains are mostly hydrocarbons or grease, oil, they are mostly hydrocarbons, non-polar. So the tail of micelles or the tail of detergents are non-polar. The non-polar part of detergents make contact or make bond with the stain, with the non-polar stain, and they collect themselves or aggregate themselves around the stain, as is shown that micelles are liquid molecules that arrange themselves in spherical form in aqueous solution. Or this formation of stain is because of the amphiphatic. This formation of micelles is because of the amphiphatic nature of fatty acid, meaning that they contain both hydrophilic region, that is polar head group, and hydrophobic region, that long hydrophobic chain. When all the detergent molecules aggregate themselves around the stain with their non-polar and forming bond with the stain, their polar head is surrounded, their polar head all away covers the stain molecule. And when this polar head interact with the water, when we wash the clothes, when we wash the stain or we drain out the detergent, then this polar head part form bond with the water molecule, and that's why stains are moved out of the whole structure. Like अगर मतलब ये स्टेन मॉलिक्यूल होते हैं ना, ये स्टेन मॉलिक्यूल के साथ बिकॉज ये नॉन पोलर होते हैं, तो हमारे डिटर्जेंट्स का नॉन पोलर हेड इन स्टेन मॉलिक्यूल के साथ बॉन्ड बना लेता है, और जब हमारे ये बिल्कुल कवर कर लेते हैं हमारे स्टेन को, लाइक एक बॉल होती है ना, बॉल के ऊपर बिल्कुल वो उसको कवर कर दें, तो उस तरह से ये बिल्कुल उसको कवर कर लेते हैं। और जब ये वाटर के कांटेक्ट में आते हैं, बिकॉज अब बाहर हमारा सिर्फ पोलर हेड पड़ा है, ठीक है। अब बाहर हमारा जब पोलर हेड इसने तीनों साइड से 3 डायमेंशनली इनको एक दूसरे को सराउंड कर लिया, तो हमारा बाहर सिर्फ पोलर हेड पड़ा है जो हमारा वाटर के साथ इंटरेक्ट करेगा जब हम अपने क्लॉथ्स को वॉश आउट कर रहे होंगे। तो जब ये पोलर हेड हमारे वाटर के साथ इंटरेक्ट करेगा तो ये रिमूव हो जाएगा, ये बाहर मूव कर जाएगा, हमारे वाटर के साथ ड्रेन आउट हो जाएगा। इस तरह से डिटर्जेंट हमारे स्टेन्स को रिमूव कर देते हैं। Proceeding to the next slide that represent critical micellar concentration. Critical micellar concentration is defined as the concentration of the detergents above which micelles are spontaneously formed. Agar that represent if you put a small amount of detergent in a lot of water, that is not going to form micelles, because each water concentration have a particular amount of detergent above which micelles are formed. Okay, so when you put or you add detergent into this water, when the detergent level reaches a maximum critical concentration, above that spontaneously micelles start formation. So the concentration of detergent above which easily micellar concentration formation start occur, that is critical micellar concentration. It is important in biology, as important as detergent form complexes with lipophilic proteins. So detergent when form complexes, so this is an important phenomena in biology, and critical micellar concentration is considered as an important thing